Hello, it is Mrs. Scarpel, and in this video I'm going to take you through the process of completing the square to create perfect square binomials. So the first thing I'm going to do is I am going to draw a square. Because everything is built off of a basic x by x square. A square with sides length x is going to have the area x squared. Now if I look at my expression here, I see that I have a plus 4x. I am going to create additional parts to my square. I'm adding to my square to create a total of 4x. Now notice that one side has the length of x, so this side here also has the length of x. If I add a rectangle that has a unit length of 1, and this side is x, this rectangle is also going to be x. And I'm going to put a matching one on my other dimension so that it is also an area of x with a unit dimension of 1. Now this is only 2 of them, and I have a total of 4 that I need in my diagram. So I'm going to place one more on this side for a total of 3x, and another one with a unit measurement of 1 along the bottom for another area of x. So I have 1, 2, 3, 4. But now I have this region in the lower right corner. Well, that's created with 2 columns from my unit measures on the side and 2 rows from the unit measures that I added on the bottom. Each of these squares is 1 square unit in area. So I can complete this expression by adding these units to it. I have x squared plus 1, 2, 3, 4x plus 1, 2, 3, 4 units. So this area can be written as a of x equals x squared plus 4x plus 4. But I could also write the area using the dimensions. I could write it as a of x equals the length of one side, so one side is going to have the length of x plus 2. Because it is a square, both sides are going to have the dimension, or both dimensions are going to have the length of x plus 2. And we know that to find the area of a square, we can use length times width or base times height, but what it boils down to is the length of one side squared. So this would be an equivalent equation for the area of this square. So if I take a look at this one here, I have x squared plus 8x plus what? So again, I'm going to start with that basic square. I'm going to label it x by x, and it's going to give me my x squared, that first term. Now if it's a square, these linear terms, the 8x, needs to be divided evenly. So half of them need to go on one side and half of them need to go on the other dimension. So half of 8 is 4, so that's going to be 1, 2, 3, 4. So we have x plus 4. And each of these has an area of x. Do the same with the other dimension. 1, 2, 3, 4. And each of these also have an area of x. So now we have our 8x, and we need to find how many unit squares fit this lower right region. So we have the 4 rows, and we're going to have 4 columns. Each of these has an area of 1 square unit. So 4 by 4, 4 rows of 4, is going to be a total of 16. So one equation for area is a of x equals x squared plus 8x plus 16, or we can write it just using the dimensions. A of x equals x plus 4 squared. The next one I'm going to show you has a larger yet linear term, has 14, and rather than draw each individual unit rectangle, I'm going to show you how you can go ahead and represent everything without each individual piece. So I am going to make it so that I have a square that is x by x and have the area x squared. Now I know with the 14, I'm going to have to split that evenly with my 2 sides. So that would be 7 on one side and 7 on the other side, because 14 divided by 2 is 7. So this region will have an area of 7x, and the one down here on the bottom left will also have an area of 7x. So then this lower right corner is going to be, think of it as 7 columns by 7 rows, so 7 by 7 is 49 square units. So x squared plus 14x plus 49 is a perfect square trinomial. So one of my area equations is a of x equals x squared plus 14x plus 49, or a of x equals, using the dimensions of the sides, x plus 7, close our parentheses, squared. This will work if our b value, the coefficient on the linear term, is negative. It will also work if it is odd. If it is negative, you're just going to end up with x minus something. If it is odd, you're going to end up with fractions for your value of c and for the amount that's being added on. But the process will still work. It will always be that this value of 49, or this c value, will be half of the b value squared. So if we have if a, I'm not going to write the a, if x squared plus bx plus c is a perfect square trinomial, then c equals the b value divided by 2 squared. And this concludes the video on completing a trinomial so that it becomes a perfect square trinomial.